Hello everyone, welcome back to another video. In this video, I'm going to be showing you guys how to implement a sorting algorithm known as Stalin Sort. Basically what it is a algorithm that iterates through a list of values and it checks to make sure they're in order. If a value isn't in order, it gets removed from the list. It's pretty straightforward how it works, and honestly, I don't know where you would use Stalin Sort since it removes values. It basically runs in constant time, so O of n, it's an O of n algorithm, but with the trade-off of you losing values or losing data from your list. Since I don't have any insane animating or anything like that, or animations or whatever the hell, I'm just gonna draw a little picture here. For example, let's say we have this list here, this 4 number list, 4 integer list. Basically how it's gonna work is we're going to start off at 2 and then we're going to compare with the next value, and we're going to check if this value is greater than 2, if not greater than or equal to 2. If it's not, it's going to get removed from the list, and then we're going to compare this value with the next one, and if it is greater than or equal to, it stays in the list. Then we're going to take this value and then we're going to compare it with this one, and we're going to check the same thing. Basically that's how it works. And let's say, for example, I don't know, there was another one here for whatever reason. Let's say we check over here and this one is less than 5, it'll get removed. That's pretty much how the whole thing works. So your array would be 2, 3, 5. Obviously we lost 2 values from our list. Like I said, I don't know where you would want to implement this in the real world other than for a meme, but let's go ahead and get right into implementing this. I'm going to be using Java for this. You could follow along with Java as well, or any other language. Okay, so basically I already set up half of the thing. I didn't do the sort yet. I already know how I'm going to do the sort. I've done it and then I deleted it just to make sure it works, but I'll go over it again. While I'm going to recode it and try to refactor it a little bit. But the first thing I do want to mention here is I do have my basic setup here. All this is doing here is I'm going to create a new array here with a size of 10. I'm going to get a new variable to keep track of the array length basically, and then I'm going to go ahead and populate the array with random numbers. I created a method that will generate random numbers between a minimum and maximum value, and then you can assign those anything. So I just set it to 1 to 100. So basically what's going to happen is this array of size 10 will have values or random values between 1 and 100 in it, and this is obviously my sort method call here. I pass in 2 parameters, an array parameter and a integer parameter. The array parameter will keep track of my unsorted array, and the integer will just keep track of the length. And yeah, so that's pretty much it for this main part. Now for the sorting method, I just call it Stalin Sort, and then again I still do pass in 2 parameters. And we're actually going to be using 2 arrays. So we're going to use one array, this unsorted array. Then we're going to use a second array known as a sorted array, which is going to be of the same size as the unsorted, because we're not using dynamic arrays, we're using regular arrays, so we do have to initialize a size. So obviously just give it the same size as the last array. Now you may be thinking that it loses value, so how is it going to be the same size? Arrays will default to zeros. Well, we're actually going to create a new variable that keeps track of only the sorted size, and when we print out the sorted array, we're going to only loop through the sorted size integers, or the sorted size in the array. It'll make sense when I get through it. Okay, so this just prints the sorted unsorted array. I loop through the entire array, and then I go ahead and just print the value at that specific index. That's pretty much all this will do. Alright, so let's go ahead and start implementing the sort. So the first thing I do need to define in here is going to be a sorted length, because remember, we only want to print the sorted length of the array, not the entire thing. If I didn't keep track of this and I printed the entire sorted array after we've sorted it, it's just gonna print a bunch of zeros afterwards. I'll show you guys what I mean when I get there. We set it to a fixed size of unsorted array size, and when we loop through it, remember Stalin Sort removes values that aren't in order. So there's gonna be extra space in our sorted array that wasn't used, and that's gonna get printed, but we don't want to print that. I mean, you could if you wanted to. And then the next variable I'm gonna actually need here is another variable that keeps track of the first index in my sorted list. So arrays obviously work they start off at 0, then 1, 2, 3, and so on. I guess I'll use an example as I work through this. So for example, let's say we had 1. Actually, 1 is fine. You know what, now let's do 9, so I can actually put some other numbers here. Actually, you know what, let's just do 1, and then we'll have 4, then we'll have 2, and 6, and then we'll put 3. Alright, so let's keep track of this list as we're going on here. So obviously arrays will start off at 0, 1, 2, 3, 4, just like that. That's how arrays work. Pretty simple. I'm not going to go into too much detail because I do expect you to know some basic things like this. These two variables are going to be useful for the rest of this. So let's go ahead, and we're actually going to want to create a for loop. Yeah, I'm going to set it I to 0. We're going to start at the 0 element, or the 0 index, sorry. We're going to go ahead and say if I is less than length, I increments. So basically index I will be, we start off at the 0 index, and we're going to loop through the entire unsorted array. And yeah, that's pretty much what this loop is doing. Alright, so the first thing we want to check is the unsorted array's first index. So inserted array of I, which is at 0, if this is greater than or equal to the sorted array of sorted length minus 1. Okay, what this is doing is we've initialized our one array, we've initialized a second array, which was right up here, with the length of unsorted arrays. So we have a second array that contains 5 zeros currently. So this is all I'm doing here, is now checking if my unsorted array of I, which is 0, unsorted array of I is currently 0, 0 index, which is 1, if this is greater than or equal to my sorted length minus 1, sorted length is 1, so 1 minus 1 is 0, is this greater than and equal to 0? That's what this is checking. If so, we're gonna do something. We obviously want this number to go into here because we want to update our first index. So that's why we used first index in sorted. If I didn't do this, what would have happened is this would have updated this value instead. It would update this value because we do have some code that goes ahead and starts doing updating these other values. So let's go ahead and use our first check. So we do want to check this statement we're writing will only run once because we're only going to check for the first index in sorted. So this is what you're going to put. If first index in sorted equals 0, whoops, then I want to go ahead and update sorted array of first index in sorted, and we want to go ahead and assign that the value in unsorted array of I. So this basically updates 0 is now going to be 1. Boom. Okay, we don't actually change anything in our original array. We're just updating a second array. We're looping through this one array and updating this second array. Because, as you know, removing elements from an array is very tedious work. We can remove this element, but this is still going to be a 0. We'd have to shift everything over, and we'll still have zeros at the end because the size is fixed. We're not using a dynamic array where the size could change. I guess a linked list would be pretty good to implement this on, so that since we could remove from the middle, still reconnect stuff, but we'll just use an array for now. So that's what this is doing. And now we want to actually update first index. 0 will become 1. If we don't do this, it's going to keep going back in here and checking first index, and it's going to keep changing our 0 element, which we don't want to do. We want to add to the next values in our list. Like what would happen next is 4 would have went in here instead, and we don't want that. Okay, so now we want to do else. This is where the other operations would occur. So we want to do sorted array of sorted length, which is going to be equal to unsorted array of I. Okay, so sorted array of sorted length is 1. This will occur on the second iteration through our for loop. Okay, and then we also want to go ahead and iterate or increment sorted length by 1. Just like that. So let's go ahead and review what's going on here. So obviously we've already went through here. We've entered 1 into here, into our second array. Now we're going through our loop again. I is now 1 because we've incremented I right here. I is now 1. I is definitely less than the length of the array. And is this value greater than this value? We're checking this last value here. Index sorted -1. Is it greater than this last value? Yes, it is. And then we're going to check in here. Is first index in sorted 0? Nope, because we incremented that already. So this is 1. Then we're going to skip this code. And then we're going to go down here. Sorted length is still 1 in this case because we never incremented this. We went here. So sorted length is still 1. So 0, 1. And 4 gets updated into this value. Alright, now the next one here is a 2. Let's see what happens. The next value is not greater than or equal to. Is this greater than or equal to this value? No, it's not. So then nothing occurs. We just go ahead and run back through our for loop again. And then we check this value, and this value goes in here. And we check this value. Is this greater than or equal to? Nope, it's not. And our end array is 146. So let's go ahead and print our sorted array. Okay, so let's go ahead and type in here system dot out. Okay, I can't type right now. System.out.print println, and I'm gonna put in here sorted array. And next up, I'm gonna do a for loop. So we want to iterate through the sorted list. I'm sorry, the sorted length. Well, j is less than sorted length j plus plus, and then we're gonna go ahead and print the value at sorted array of j. So j, why do I keep doing that? Boom, just like that. And I'm just gonna add a space, and let me just go ahead and format. Okay, there you go. So now this should work. Again, remember I added in random numbers from 1 to 100 in a array of size 10. So let's go ahead and see what occurs now. Okay, there you go. As you can see, we have our unsorted array, which is this list right here, and our sorted array, which is 24, 48, 49, 93. Is that in correct order? Yep, 24, 48. This is less than. 93 is bigger than 49. This is less than, this is less than, and this is less than, and this is less than. So this is our array. Let's run this again. See, just to make sure it works. I'm just gonna clear, and we'll run it again. same deal. 46, 85, less than 98, less than. Yeah, so that's pretty much how that works. Yeah, so that's pretty much all I got. It's pretty interesting sorting algorithm. Not sure what the next video is going to be, but yeah, that's pretty much all I got. See y'all in the next one.